this issue at your end, then we'll come back to you again. Actually, your voice is not clear also.
Maybe we can give the presenter right one at a time. One at a time, then it will be good.
Yeah, we can take this presentation at the end.
Yes. So paper number 456, please. You may present.
Madam, now
Paper
stop
ID.
sharing the screen. Please stop sharing the screen.
Gaganbin Kaur, kindly unshare your screen so that other can share.
Actual laptop, it's just
Otherwise, you leave the session and again log in. Okay, shall we call next one?
Yes,
Our next
456.
presenter is paper ID 456.
Hello. Yes, it's ready. Good evening.
Yes, sir, you can
Yes,
share
you can
your
start.
screen and start the presentation.
Okay. Can you see my screen?
Yeah, it is processing. Yeah, go ahead.
Okay. Good evening. I'm here to present Hausa character recognition using logistic regression. So we have the table of contents.
Can you on your video and give the presentation while presenting on your video, please?
Okay. Okay.
Your screen is unshared. Share your screen.
Okay. Hello.
Yes, sir. Visible and audible as well. Please start.
Okay. Is it visible now? Can you see it now?
Yeah, you go ahead.
Okay. Okay, I have the table of contents, which have the background, the literature review, the problem description, the methodology, the result discussion, the conclusion, and the reference. So coming to the background, we have a optical character recognition system enables human machine interaction by using technology to discern published or handwritten lettering inside digital representation of physical documents. For instance, a scanned paper documents, and these are widely utilized in a variety of applications. Other categorization techniques have been used to study various languages, which includes Yoruba, English, Arabic, and some other Latin characters as well. So we have the literature survey. Despite the extensive study on Latin language, just a few studies on indigenous language have been published. Handwritten recognition researchers have looked at recognition in multiple languages as a separate challenge. Each language has its unique collections of characters and properties, making it challenging to create a universal algorithm that works across all language. Because of this simplicity and low memory requirement, researchers have utilized logistic regression to extract properties of letter or numbers. So we have the literature surveys as well. Various aspects of pattern recognition, notably in the area of character recognition, have been successfully used using logistic regression. For character recognition, some characters have used traditional approach such as segmentation and recognition, while others have used artificial neural network-based methodology. Logistics regression has been an applicable aspect in the field of artificial learning. It is explicit as a statistical analysis model utilized for prediction of dependent data value by analyzing based on the past perception of data sets. The methodology empowered on algorithm being used in machine learning application to classify data based on historical data. So we have the methodology based on the methodology. We have the design obtained and confined in the previous segments were developed by using Octave programming language. This program was Kernel using C# programming language to develop the system using interface to enable users to use the application without accessing the underlying model. The desktop application interface relied on the compiled model that was generated by the logistic regression algorithm within MATLAB program language. The program was compiled and tested to avoid errors, and an installable execution file was generated so that the package can be installed and run effectively on computer device regardless of the version of their operating system, as long as it meets the necessary hardware requirements. So the application was submitted to various testing and sample screenshots was presented. The handwritten character pictures were taken from the constructed Hausa database and tested on the recognition model to verify the built Hausa handwritten character recognition system. Pre-processing was done on the test data. The proposed feature were extracted and compared to the main featuring vectors. If the two feature sets are comparable, it searches the lookup database for the suitable character and displays the matching digital counterpart of the handwritten character if it's found or return. If it's found or return a false negative, if it's not found. So we have the results here. With these are the data being fetched, being given to the Octave, which a model is being generated. Then after this generation of this model, it was being fed to the MATLAB, which is used for the character binarization, then character recognition as well. So these are like extracting this is also an image which shows the extraction of the handwritten characters, and these are the sample Hausa language, Hausa words that were being used for the project. So, and other alphabets too were being tested, but these are just the samples being used. So we have the results. Based on the results, we find out that logistic regression has been a very good method for this, because it has accuracy of 89% compared to other methods which has 82, 79, then 82 respectively. So this was the reason why logistic regression was being chosen. So conclusion, to distinct factor of this word from other related one is that it has been implemented using logistic regression. However, a few researchers have tried using the later algorithm, yet they have not been able to accomplish up to 70% of what the project is to accomplish. Some algorithm that has been implemented in accomplishing a similar objective included at ANN, artificial neural network. We have K, nearest neighbor, then we have a support vector machine algorithm. So we are for this in conclusion, for this research study, this research uses Hausa characters, which is also a part of Hausa characters. This is a part of a language in Nigeria. So the previous project has drawn in the utilization of other language and other classification algorithm. In any case, this research focuses on the use of the Hausa character. The system user interface was developed with C# program, which I've made mention earlier. The desktop application interface rely on the compiled model that was generated by the logistic regression algorithm written in Octave language, which I've also said earlier as well. So we have the references. These are related papers and the topic to this proposed topic. So we have the references and the likes. So I think that's all. Thank you very much.
Any question from session?
Actually, in the paper 4, 5, 6, all the authors are different. Means the presenter name is Habib Abdullahi, but the name is not present in the author list. So
That's what I have also observed.
Yeah, it
can you
is.
please cross check?
Sorry, can I answer to that? I'm one of the author. I had a delay, so I knew that I was going to have issue with the connection. I tried contacting the corresponding author to inform him about it, but I could not get across because I was on transit. So I had to tell him to assist in the presentation. That's
I
why.
think
Sorry
here
about that, sir.
your name is yes. Your name is there, but 2 times Deepak Singh is there. Means the presenter name is not here. That's why some confusion.
Yeah, so he's my student, and none of the authors were available to do the presentation because of the short time I had to inform him. So I later joined when he was presenting.
Is it okay,
That's
Kavita
why, sir.
ma'am?
Thank
At
you,
your
sir.
end, Miss.
Let me ask, sir, I don't know
No,
whether we
what
have to
can do, sir,
Yeah.
Neeraj sir,
Yes, sir.
ultimately we have to wind it up. So let Rosalind madam answer the questions, at least that we can do.
Okay, okay, sir. Yes, sir. Question answer session may handling.
So at least the author should respond to the questions or the queries that are being raised.
Okay, okay, yes, yes. If anybody wants to ask any question, then please.
Yeah, I have one very fundamental question like that. Already there has been a lot of work which has been done on this field, hand character recognition. In what way this particular work is different? So, and other things that basically this logistic regression that you are discussing, to the extent I understand, you are using it as a classifier.
Introduction part, we said work is that others have used Latin language, but we decided
so
to
for
go
Latin language, nobody has used logistic regression previously for recognition of characters in Latin language.
No, we saw there was a work that we compared with that used in Latin. But
And
our own.
Okay, fine. And that logistic regression is a classifier.
Yes, sir.
What you are feeding as an input to the classifier,
No,
the
text,
image.
Text character, outside text characters. We use
Text character, the image of the text character, you are extracting some features from that image, or
no,
text character, just you are feeding it the characters only to the logistic regression.
We fed in the character. It was just the screenshot of the feeding of the character.
The image of the character, no? The image of the character.
No. The character, the outside character itself, one after the other, it was entered into the system.
Okay, fine.
Yes.
Okay, let's move to the next presentation. If no questions remaining. Okay, we'll start for the next presentation, 479. Dr. Umesh Gupta, sir.
Yes, sir. Am I audible, sir?
Yes, you are audible.
Yeah.
Please start your presentation.
Yeah, wait a minute, sir. I'm sharing my screen.
Okay.
So my screen is visible to you?
Okay, yes, clear.
Yes, visible.
Yeah, sir. Shall I start?
Yes, please, you can start.
Okay, sir. So good evening, all of you. Myself, Dr. Umesh Gupta, and currently I'm an assistant professor in Barrett University. Today I'm presenting a new model in the classification named as intrinsic fuzzy kernel random function link classifier. So these are the table of discussion, conclusion with references. So when we are talking about the background, as we always hear conclusion with references. So, and its kernelized version is like the popular machine learning model in the like 90s and 80s. But after that, it was like citing the work on over the RVFL was stopped and SVM was growing. So in 1995, we know that like SVM support vector machine was the very growing classification model which used in many applications. But in recent years, like P.N. Suganathan, who is a professor in NTU, who has started some works on like RBFLs, and some recent works are recently done on RBFL. So one of the latest work in 2017, like kernel-based RBFL, that also known as like kernel implementation of RBFL, which work for high generalization and quick learning. It is designed to avoid the selection of number of hidden nodes and hidden mapping function. So it is well capable to deal with the complex process more effectively due to the complexity in the kernel. So when we talk about the literature survey, so as we know that fuzzy support vector machine already show that decent generalization performance with various data set, and the noisy data set basically we can say, but it gives some same fuzzy membership to all the training samples. But we know that in the real world, each and every sample is not same, so we can't give it to the all similar fuzzy values to the all the samples. So for Atomistov suggested the internistic fuzzy sets, which is more precise in addressing uncertainty concern and enables precise modeling based on existing data. So on the basis of Atomistov approach, so recently you can say like a support vector machine based on internistic fuzzy method was suggested, which lessen the influence of noise to some extent in classification problem. But as we know that support vector machine are follow the structural risk minimization principle. So it takes like we have to solve large QPP. So it requires high computational cost. So for reducing that high computational cost for IFSVM, there's a need to be, like a need of twin model. So we know that like Reshma Khemchandani and Dr. Jadeva already proposed the twin support vector machine model. So according to like the IFSVM, it reduces the the influence of noise in the data set. So we the Rejwani et al. Have embedded the internistic fuzzy based method into twin SVM, and it gives wonderful performance because it solves like the computational cost. We are not going to solve a bigger QPP, we are going for solving two smaller QPP quantity programming problem. Then further reducing the computational cost, recently in 2021, Hazarika have done some work on, on similar work like IFSVM and IFSVM on KRR. So like internistic fuzzy based KRR was suggested, and it gives wonderful performance. So similar to, the motivation from that, I have implemented we have followed the model kernel based RBFL, and here we know that it shows the high generalization quick learning, but where the selection of number of hidden nodes and number of hidden mapping function, it lose something. So we use like this to boost up the generalization performance of KRBFL. We use internistic fuzzy value over the KRBFL. So these are the notation where we used like dimension of input vector matrix, activation function, hidden layer neurons, and non-mapping functions and feature mapping function like that. So here the centered of binary classes like pod, n plus, n minus like that. So when we know the problem description, so we have the mathematical expression of RBFL, like, and we know that how to solve this RBFL simply, like, it's a R is an augmented matrix, and we can easily find the value of output weights. And here, like R transpose indicate the transpose of R, we know that, and we simply get the final classifier. As Pao et al. Already proposed this RBFL as a universal approximator, but there is a great need for improvement of generalization and quick learning, as well as the problem of selection of number of hidden nodes and hidden mapping function is also there. So we improved this one using like internistic fuzzy based method. So we know that the internistic fuzzy member degree is given by the Atisno and Rezvani already used in the IFSVM and IF2SVM. So here we have the IF internistic fuzzy based member degree function and the non-member, you can say non-membership value. So we will put it like the data points like according to the membership and non-membership depends on their value, depends on this score function. Then we embedded this score value in the RBFL, kernel RBFL, and we solved it simply. And to summarize, like, we can say we don't need to choose the number of enhancement node on the appropriate incorporate mapping function. Rather, we must provide the corresponding kernel function, the previous one. So we have tested our proposed method on 14 data set. These data set are required from the UCI repository, and we have compared this with the IFSVM, IFTSVM, RVFL, and KRVFL. And we also calculate the rank of these models on this data set. So along with this, we just got the average rank is 1.67, which is very least. So we understand that like our model is a first rank model, and when we apply wind tile loss, so out of 14, we just get it like we can see like 12, and on the 12 cases, our 12 data set, our model wins, and in 2, it is you can say tie or lose. So when we talk about the average accuracy of the classifier, along with this, we can see that like the accuracy is also better in comparison of other models. Here we can see the average accuracy rank. So average accuracy rank of IVF, KRVFL is also better in comparison to the IFSVM, IFTSVM, RVFL, and KRVFL, because we know that like RVFL is the least square method, so it takes less time. So whatever problem we have in the SVM, twin SVM, so the problem is easily solved here. So this work suggests novel kernel-based RVFL model based on intrinsic fuzzy number, and in the proposed IFK RVFL model, intrinsic fuzzy number is associated to all training sample, which consists of membership and non-membership. So all the experimental results on you can say the 14 real-world data set what I have taken here to solve the real-time classification problem, and in the future what we can do, like it can be remodeled for solving the multi-class classification problem, and as well as we can implement with some applications. So these are my references. Thank you. Any question? Hello.
Is there any question from the participants?
So, Dr. Gupta, I have one.
So your voice is not completely audible.
Right now it is audible. Can you hear me?
Yes, sir. Yeah, sure, sir.
Okay. So first of all is that whatever that the results that you have shown all are for binary classification cases?
Yes, sir.
Like,
it is all
okay.
for binary classification, sir.
And like SVM also, you can extend it for multi-class classification also.
Sir, till now I have, yes, sir. Each and everything is for binary classification, all results, sir.
Okay. Now, another thing I wanted to know is that my basic what you call experience is that the selection of the kernel parameters is a very tedious task. Okay.
Yes, sir.
I'm talking of the classical SVM where the Gaussian membership function, the spread and the mean. So likewise, I suppose that for this IFK RVFL also, there are many tuning parameters, okay, the membership functions and all that. So how you have optimally selected them?
No, sir, we have taken the range,
parameters.
sir, and simply use the k-fold cross-validation here. Like there is no need to, like tune the parameters. We have taken the range. And like before, like when we talk about the KRVFL is already taken that range. So they already proved that these parameters are when we select that parameters, so it gives the better results. So we just take those variables, okay, and as well as we just put it the intrinsic fuzzy number. So on the basis of this, the intelligent performance is improved.
So say from existing paper, you have taken the parameters for that and then started from, is it like that?
No, sir. Actually, sir, KRBFL is, that work is already done by one of my senior. Okay. And he already published that work. So we have tuned that parameter that time. So that time,
okay. That time you have tuned, and those parameters you have extended it for this IFK also. No, but when you say that you have tuned it, it is purely on a trial and error basis, no? Or you have
every time it can be possible, sir.
Okay. So there is a possibility that the performance may be even better than whatever that you have got.
Yes, the performance can be better, sir. And the thing is that here, I can say I haven't mentioned the scope. It can be further work for like outliers also. I have worked for the noisy data set, but here outliers work is still remaining.
Okay, right. Like recently, there are many papers where they have used grid search and other optimization technique for tuning SVM and all that. Maybe you can look into that.
Yes, sir.
Optimal tuning of the parameters. Okay.
Yeah, sure.
Okay, fine. Thank you. Nice presentation.
Thank you very much, sir, for your kind question. Sir, any questions from others?
Okay, thank you, Dr. Ramesh.
Thank you very much, sir.
Oh, okay. Now next move to the last presentation.
I would like to call Mrs. Gaganbin Kaur, paper ID 383. But ma'am, you have
Yes,
to
ma'am.
wind up your presentation in 3 minutes. Actually, there is a time constraint right now. You just summarize your work in 3 minutes.
Okay, ma'am.
You can come to your methodology and summarize it.
Okay, ma'am. I will try.
Now 5 minutes.
Okay, am I audible?
3 minutes is very less. Anyway,
Yes.
sorry for it. Yes, yes, you are audible, madam.
Am I
Please.
audible, sir, please?
Yes, yes, you are audible,
Okay,
and
sir.
your slides are also visible. Please.
Okay, sir. So I'll start with just giving a brief introduction in 1 minute. So this presentation is about the intelligent transportation systems, where we have used some machine learning techniques to predict the future traffic. So we're trying to predict the few parameters, like we have used speed as a parameter to predict the congestion in the traffic, and then accordingly we have used some like algorithms like recurrent neural networks, LSTM, gated recurrent units have been used. So here we have used graph convolutional networks and gated recurrent units. We have combined both of these. So there are actually two basic parameters in traffic prediction, which we are trying to capture for efficiently predicting. And those are the spatial and the temporal features. So in case of spatial features like the connected roads, so traffic between these connected roads is always dependent on each other. So it's very important to capture these parameters, and graph convolutional networks efficiently captures these parameters. Secondly, the temporal features, like the traffic is always dependent on the time domain. So we have combined these two factors. I think I should skip the literature survey and directly come to the problem description. So in problem description, like I said, we have combined graph convolutional networks and gated recurrent units. So using the graph convolution networks, we represent the whole road network as a unweighted graph. So, and we find out an adjacency matrix A. So this matrix actually represents the connectedness between the nodes. So we calculate the distance between two nodes, and these two nodes, like here it's shown, it's Di and Dj are two nodes. And using this formula, exponential minus distance Di dj square upon the sigma square, that is the standard deviation, we will finding the distance between two nodes. Now, next we have set a threshold, and we have selected a value of 0.1 for the threshold. And if this distance between two nodes is greater than this threshold value, so we will set the matrix that component as Dij. Otherwise, if that otherwise it's got this GCN, we need another matrix, that's a feature matrix, and this matrix actually contains the attributes. Like we have the speed, like we have chosen a speed as an attribute, so that contains the speed. So speed at the various time points. Along with this, we have used clustering. So we have combined GCN, GRU, and along with this, we have used clustering. So clustering is very important in when we talk about wireless sensor networks, as clustering actually reduces the amount of traffic between the node and the base server. So it reduces the communication overhead, and also it reduces the computation time. So we have concentrated on the computation time in this case. So apart from clustering, we have used fuzzy means, C-means algorithm for clustering. And again, adding to it, we improving the quality of the clustering by calculating the variance within the cluster. And this not variance. We have calculated the variance for different cluster, and then we have calculated, we have plotted this, and we got the number of clusters for where we get the minimum variance. So that actually falls between 7. So we have then clustered, and then we have applied our GCN methods. Next, so after this, so the data set we have calculated, which we have used is from California Transport Department.
We have used the time series data every 5 minutes for 1 week data. These are few of the parameters, like learning rate, we have used 0.01 or 64 hidden states. And then we have calculated the root mean square error. That means error between what is predicted and what is actual values, and mean absolute error and the accuracy. This is the plot showing the root mean square for our proposed approach. So this plot shows the RMSE value for testing and training. So how much, like 80% was for training and 20% was for testing. So we have achieved quite a smaller RMS value, and this is the accuracy of our approach. And then we have compared our approach with the TGCN model. The TGCN model is temporal graph convolution network, which again uses GCN and GRU. So we have introduced clustering into it, and we have
Yes,
almost.
Yes, madam, can you please conclude?
Yeah, this is the final slide, sir. So this is almost the same accuracy we have achieved, but what we gain here is the computation time. So we have almost achieved a 50 times gain in we have improvement in computation time. So finally, I'll conclude here. So this is what we have already said. We have achieved a 95% accuracy, and we have reduced the computation time up to 50 times as compared to the base paper like we have selected. Okay, so thank you, sir.
Any questions? Okay, that's all.
Just one quick question, very quick question. So each time
Yes.
you run that FCM algorithm, you are coming down to the same result, or each time with a different initialization, the final convergence results are different?
So conversion results with different data, you mean to say?
No, same data, but different execution.
Different executions, yes, a bit difference.
Okay, fine.
Not very large.
Fine. Yes, sir, we can conclude.
Okay.
Neeraj, sir?
Yes. Yes.
Okay, with this, we have completed all the paper presentation of this session today. Now, I take this opportunity on behalf of NIT Chapter and organizing committee of the conference. I thank you all for sharing valuable time as well as providing valuable insights to the author. Thank you everyone for making this session successful. Now you all can log out of this session. Have a nice day.
Thank you.
Thank you to all.
You all are requested to join the validatory session.
Okay.
Thank you.